All right, so now let's talk about what is called the snake or zigzag lemma. Okay. Okay. So, um, so let's have a short exact sequence of chain complexes now. Okay. So we have a U, we have a V, we have W. So these are individually chain complexes. Okay, with phi and psi. Right. So this is a short exact sequence. Of chain complexes. Okay, so if you recall, it's like what that means is that in sort of the vertical directions, it's like they're individually chain complexes, right? And across horizontally, it's like for every dimension p, it's like that is a short exact sequence. In addition to that, right, these chain maps, right, commute, it's like with the boundary operator. It's like for each of the chain complexes. Okay, so all right, so in that situation, then there is a well-defined map. Let's call it D from the homology, it's like on W to the homology on U of one lower dimension, right, which is called the connecting homomorphism. Such that HPU, HPV, HPW, HP minus 1U, and so on, where this is the D map, the connecting homomorphism, right, is a long exact sequence. Right, and as you recall, hopefully, right, that these two maps, right, because they are chain maps which commute with the boundary, they induce homomorphisms at the level of homology, right? So the maps from HPU to HPV to HPW are just induced by these two chain maps. Okay, so the only part which is missing, it's like in this construction again, is this connecting homomorphism between the p-dimensional homology, it's like of W, with the p-1 homology, it's like of U. Okay. So, so the point is that other than the connecting homomorphism, right, the maps, the other maps in this long exact sequence are induced by the chain maps. Okay, so in a little bit, it's like we'll be talking about how to construct it's like that connecting homomorphism. All right. But as you might expect, right, the snake lemma or the zigzag lemma, right, gives you a means of sort of recovering. It's like the exact sequence. It's like for the pair, right, which I had sort of previously talked about, but let me just remind you of. Okay, so the snake lemma sort of gives rise to the exact sequence for the pair. Let's say k comma k0, right? And it's because the inclusion maps, well, I can call it inclusion and projection, if you will, maps. Right? From, that's just, okay, so I'm going to omit the dimension here because these maps give you actually a short exact sequence of chain complexes, right? So CK0 maps to CK, right, via the inclusion, maps to CK comma K0, right, by, if you want to call it the projection or the inclusion, however you want to call it, right? And this is a sort of short exact sequence, right? Right, yield a short exact sequence of chain complexes. Right. And of course, it's like, so it satisfies this condition, and then you can directly apply this snake lemma to give you the it's like the exact sequence for the pair, right? So I should say that then applying the snake lemma gives the sort of exact sequence for the pair. All right. Okay, well, I guess you have to show, obviously, that this is a short exact sequence, right? I mean, intuitively, it's like that should be clear, right? Because all things in CK, it's like come from this relative class, something in the relative class, and something it's like in K0, right? Yeah, I mean, it's like one has to check this, it's like, but it should be relatively straightforward to show. Okay. Okay, so yeah. And then this is the connecting homomorphism, right, to the lower dimensional homology. Okay. All right. So, all right. So what I'm going to do next is to show you how to construct this connecting homomorphism. And what you'll see, it's like in the proof of that is sort of a hint as to why it's called the snake or zigzag lemma. It's because it's going to, as we saw before, right, it's going to involve the chain maps sort of horizontally, it's like, and then the boundary maps vertically associated with chain complexes. And we're going to use the fact that we're going to use exactness, right, horizontally together with the fact that maps commute, right, that the chain map commutes to the boundary, right, in order to snake through, it's like that two-dimensional lattice, it's like of maps, in order to construct the connecting homomorphism. So that's going to be why this lemma is called the way it is because of the way you construct this connecting homomorphism. It's like by snaking through this sort of lattice of maps. Okay, so let me just stop here for now.